Hello, dear students. Topics of my class is projectile motion, angular projection or oblique projection. That means it is the second part of the projectile motion. Today we will learn all about the oblique or angular projection of a projectile. First of all, what do you mean by oblique or angular projection of projectile? Projectile fired at an angle theta with horizontal, that is known as the oblique projectile. Let us consider that a projectile is fired with velocity u at an angle theta with horizontal. The angle which the direction of projection makes with the horizontal is known as the angle of projection or angle of departure. That means here the u is not horizontal. The initial velocity that is that makes an angle theta with the horizontal. Even if it makes an angle theta with the vertical, then it will be also known as the angular or oblique projectile. Here the angle with the horizontal we are taking, it is angle of projections or angle of departure. If air resistance is neglected, then we can assume that the projectile is moving under a constant acceleration a, and that is equal to minus g. Here we consider the origin, that is at the point of projections, and that is the 0 or 0 0 x coordinate or y coordinate. And in this case we are taking vertically upward direction, that is the y direction is the positive directions, and ox direction, that is the positive x-axis, positive direction of the x-axis, and the initial velocity u, angle of projection theta, theta is the angle between the u vector and the horizontal directions. Now there are two components of this initial velocity. One is along the x-axis, that is the ux, that is u cos of theta, and another vertical component along the y-axis, the uy, that is the u sin theta. Resolve velocity u into two components, ux, u cos theta, horizontal components of the velocity, which remains constant for the motion, because here also there is no other forces acting on it. Projectile means when the object is moving under gravity alone. That means the gravitational force acting vertically downwards, acceleration due to gravity also along the vertically downwards directions, and there is no component of it along the horizontal direction. Therefore there will be no acceleration along the horizontal directions, and as a result we will observe the object is moving here with a constant ux or vx, that is the u cos theta. The component uy, that is the vertical component of this initial velocity u sin theta, and this component changes under effect of gravity. Under the combined effect of both motion, the projectile moves as shown in the figure 1. That means throughout the whole path there are two types of velocities. One is along the horizontal, along the vertical, and the resultant velocity is will be the vector sum of vx and vy. There is a combination of v and vy. So here also we have to find out the equation of the path. That means what will be the nature of the path, what will be the maximum height attained by this projectile during its motion, at any point what will be the velocity, what will be the maximum horizontal distance traveled during the time of flight, and also visually what will be the time of flight, what is the ascent time, that means time to reach point A, and what is the descent time, time from A to B, and what is the total time of flight. These are the related terms or related topics of this oblique projectile. First of all, we have to find out the equation of trajectory of projectile. Again, I am saying equation of path means nothing but the relationship between x and y, where x and y is the coordinate of p, x and y, and p the any point on this trajectory. Horizontal and vertical distance traveled by the projectile motion in time t. Let us suppose x and y after time t. When it started from the origin, we take time 0, and after time t, that any point p, the position of the point p is the x and y. That means in time t, the projectile moves a horizontal distance x and also move the vertical distance y. As the acceleration along horizontal direction is 0, so the velocity of projectile in horizontal direction is constant. Already we have know it. Therefore, motion of projectile at any time t along horizontal directions. Previously, we also deal this type of situation. When we consider the horizontal displacement, we have to take along the x-axis equation of x, that is x is equal to x naught in plus ux into t plus half into ax into t square. And we already know that x naught is 0 because the projectile is thrown from the origin. Initial position is 0. Ux, that is the u cos of theta here, that is the horizontal component of the initial velocity. And ax obviously 0, there is no force along the horizontal directions. Therefore, ax is equal to, from this equation we get x equal to 0 plus ux means u cos of theta into t plus half into 0 into t square, and which is equal to u cos theta into t. Therefore, t is equal to x divided by u cos of theta. It is one relation between t at any time t and at that time what is the distance travel along the horizontal direction x divided by u cos of theta. Similarly, when you consider the vertical directions, along vertical direction velocity of projectile decreases from O to P due to gravity or changes because acceleration due to gravity acting along the vertical directions. And here we considering ay is the minus g. Upward direction is taken here as a positive directions, but the acceleration due to gravity always acting vertically downwards. Therefore, ay, that means acceleration along the y-axis, according to this frame of reference, there is a minus g. In our previous class, when we considered the horizontal projections, in such a case, we already have taken ay the plus g because downward direction was taken as the positive directions, but here upward direction of the y is taken as the positive direction. Therefore, ay that will be minus g. Therefore, motion of projectile along vertical directions y is equal to y naught plus u y naught t plus half into ay into t square. U y naught is obviously 0 because starting from the origin, and we already know that uy the u sin theta, that is the component of the initial velocity along the y-axis u sin theta into time after time t plus half into, in place of ay you have to put minus g into t square. Y is equal to u sin theta t plus half into, plus half means here it is the minus half into g into t square. Now we have the value of y and x at any instant t. Y is the u sin theta t minus half g into t square. Our target is to find out the equation of the path, equation of the trajectory. And we know the equation of trajectory is nothing but the relationship between x and y. And we have that two equations, x and y with t. Now, if we put or replace the value of t by x divided by u cos of theta, we can easily get the relationship between x and y. Replacing or putting the value t from the equation 1 in equation 2, y is equal to u sin of theta in place of t, that is x divided by u cos of theta, minus half into g into x by u cos of theta whole square, because t is the x by u cos of theta. Now this u and this u cancel each other, and that is x into sin theta by cos theta is a tan theta, minus gx square, and at the denominator there is the 2y square cos by theta. U is constant, initial velocity always constant, and the initial angle of projection or angle of projection always that is also initial one. Theta is the constant for the whole path, u is the constant for the whole path. Therefore, we get this tan theta, it is a constant term, and this term is also a constant term. This equation can be rewrite, that is tan of theta into x minus g in place of 1 by cos square theta. You can write sec square theta divided by 2u square whole into x square. For mu, you may also write y equal to tan theta into x minus g into 1 plus tan square theta divided by 2u square into x square. And any one, all these are same. At the different form we write by placing the value of cos square theta, sec square theta, sec square theta equal to 1 plus tan square theta, etc. But the form of the equation remain unchanged, and that form is y equal to a into x plus b x square. What are the a and b? And these two are constant. Here a is the tan of theta, since theta is constant, tan theta is constant, and b is the minus g divided by 2u square cos square theta. Since g, u, and theta all these are constant, therefore this term is also a constant term. That means the equations can be written in this way: y is equal to x plus bx square, and it is nothing but the equation of a parabola. And what is the equation of parabola? Y is equal to x plus bx square. It is general equation of a parabola. Here a may be 0, but b not equal to 0. If b is 0, then y is equal to ax, that will be linear equation. But here if a is 0, then y equal to bx square, that is also a equation of parabola. Since this equation, we obtain the relationship between x and y, that means equation of the path of the projectile, and in the form of the y is equal to x plus bx square is equation of parabola. Hence the path followed by projectile is a parabola when the projectile is fired at an angle theta with horizontal. That means again we get the equation of the path, that means equation of the trajectory is a parabola. In our previous class, equation of a horizontal projectile, that also parabola. Even if either horizontal projection or it is projected, any projectile is projected, object is projected with different angles, not equal to 90 degrees. Not in case of vertical projectile, the path will be straight line path. That means if you throw any object vertically directly upwards, it retraces the same path, and the path is a linear path, one-dimensional motion. But rather than any projectile, any object is thrown in other directions, even if horizontal or with any angle, then the path will be parabola. Now, some important terms related to this projectile motion. First of all, time of ascent, time taken to reach highest point. What is the meaning of the time of ascent? It is the time taken by projectile to reach the highest point during this journey. Highest point means in our figure diagram, when it is projected from the origin, the time is 0, and after time t it will reach point A, and that time is known as the ascent time, and A to B, that time will be known as the descent, time of descent, and total time, that is time of flight. So initially we are finding out the ascent time, and at the maximum height, gradually Vy decreases, and at the maximum height the Vy will be 0. That means velocity Vy in vertical directions at highest point will be 0. It is the clue to find out the ascent time. And when Vy the 0, at that time what is the t? That is t ascent. Ta means, this suffix means ascent time. And here ay the minus g, uy the u sin theta, that is the initial component by initial velocity along the y-axis, and it is the acceleration along the y-axis, that is equal to minus g. Putting all these value in this equation, vy equal to uy plus ayt, that means 0 equal to u sin theta minus g into ta, and we get ta is equal to u sin theta divided by g. It is the expression of the ascent time. And if theta is 90 degree, that means when it is thrown vertically upwards, then the sin theta is the 1. Ascent time will be u by g. And here we can also find out the ratio of the different ascent time. U and g, these are constant. Now ascent time depends upon angle of projection theta, and we know when theta increases, sin theta increases. For the different angle of projections, ascent time will be different. Let us suppose there are two angle of projection. Number one, first time theta 1, and the second time theta 2. Now ta1, that is u sin theta 1 by g, and TA2, that will be u sine theta 2 by g. Therefore, the ratio of TA1 divided by TA2 is equal to sine of theta 1 by sine of theta 2. That means from this equation, we can easily find out the ratio of ascent time of two projection when the velocity, initial velocity u is the same. Next, time of flight. Total time taken by the projectile to return to the same level of projection from where it was fired. That means when it is travel a distance and again reaches at the same level, return to the same level of projections from where it is fired. That time is known as the time of flight. In the above figure diagram, the object is thrown, is projected from the O point, and again it returned back to the B point, and B point at the same level. And if there is any hole here, the projectile may move further, but we have to consider the point B, which is at the same horizontal level of point O. What is the total time taken to fly the projectile to reach the point B? That point B is at same horizontal level of the point of projection. That time is known as the time of flight, and that is generally denoted by the capital T here. Now, when the total from the where, let us capital T be the time of flight. Net vertical displacement during time of flight is y is the 0. That means when it return back to the same level, what is the vertical distance travel? Net vertical distance travel y is the 0, and it is the clue for further proceed of calculation. Now, considering the equation, here we consider the equations of y because we are taking net y is the 0. So y the y naught uyt plus half into ay into t square. Here y naught is the 0, uy is the u sine theta, and ay is equal to minus g. When y naught is the 0, sorry, y is the 0, that means when it return back the same horizontal level, at that time y is the 0. The total time, if we consider that is capital T and it is time of flight, then from this equation we get 0 equal to 0, y naught is the 0, plus u sine theta into capital T, plus half into the value of ay is the minus g, half into minus g into t square. And from this, I am just saying again, y is the y naught uyt plus half into ay into t square. Initial position, that is the origin, therefore y naught 0. Uy is the u sine theta, that is the initial velocity along the y-axis, component of initial velocity along the y-axis. Ay the minus g, and net y is the 0 because it returned back to the same level. At that time, the t is the capital T, time of flight. So 0 is equal to 0 plus u sine theta into capital T plus half into minus g into t square. Now, from this equation, half into g into t square from right to left hand side of the equation, and u sine theta by into t, and therefore the t will be from this equation 2u sine theta divided by g. It is known as time of flight. Now there are two, either t equal to 0, that means, and when t equal to 2u by 2u sine theta by g, at that time it will reach the same level, and it is known as the time of flight. And here already we have the time of flight ascent, that is the u sine theta by g, and here we get time of flight, that is total time taken, that 2u sine theta by g, that is double of this. So obviously from this we can find out time of descent. Time of descent, total time minus time of ascent, and that will be again u sine theta by g. That means time of ascent and time of descent, these two are equal to each other. Later on we will discuss about it. Now from this equation it is clear, for same velocity of projection u, for two projectile fired at angle theta 1 and theta 2, then there ratio of the time period T1 and T2, that is the sin theta 1 by sin theta 2. That means if you take a particular gun, the u will be same for the different angle of projections. And here, if the angle of projection theta is the more, sin theta will be more, total time also will be more. Same fact also we have obtained here, ascent time, that is sin of theta 1 and sin of theta 2. And the ratio are the same because ascent time is the half of the total time of light. Now, vertical range or maximum height attained. What is the meaning of the vertical range? Now, it is the maximum vertical distance traveled by the projectile during its journey, or it is the maximum height to which a projectile raises above the horizontal plane of projection. That means from this time of ascent, in the time of ascent, what is the distance traveled vertically upwards? It is known as the maximum height. This is the AC. This height is the maximum height. And to reach the maximum height, the projectile take time, that is the u sin theta by g. From that concept, we can also calculate the what will be the maximum height. And now let us find out what is the maximum height, vertical range. So for that, we have to take the motion along the y-axis. Y is equal to y naught u y t plus half into a y into t square. And if we take h is the maximum height, y naught 0, uy the u sine of theta, ay the minus g, and time here, that is time of ascent, that is the u sine theta by g. Already we have to find out it. Putting all these value in the above equation, h is equal to 0 plus u sine theta into t. In place of t, we are taking the time of ascent, that is u sine theta by g, plus half into a y means minus g into t square. T square means u square sine square theta by g square, because whole square u square sine theta by g square. And now it is equal to u square sine square theta by g minus, here 1g cancel out here, minus u square sine square theta by 2g. And from that we get u square sine square theta divided by 2g. The maximum height, that is h, is equal to u square sine square theta divided by 2g. We can obtain the equation by another way also. We know at the highest point the vy the 0, and by using the equation vy square equal to uy square plus 2 into ay into y, from that equation also you can find out the value of the maximum height, and you get the same value. You can find out in another way also, but you always get the h is equal to u square sine square theta divided by 2g. For the same u, from this equation you can say g is constant for any projectile motion, and from the same u, for the different theta, h will be different. And when theta increases, obviously h increases. For same velocity of projection u, for the two projectiles fired at the angle theta 1 and theta 2 with horizontal, then h1 by h2 is equal to sine square theta 1 divided by sine square theta 2. Example, theta 1 is the 60 degree and theta 2 is the, let us suppose, 30 degree. That means first angle of projection is the 60 degree, and that is, let us suppose, one gun, and one bullet is fired with an angle 60 degree with the horizontal directions. And with the help of this same gun, next bullet is fired with the angle of projection 30 degree. And what will be their maximum ratio of their maximum height? From that equation we can find out this sine square 60 degree divided by sine square 30 degree, and it is root over 3 by 2 whole square divided by half square, that is 3 by 1. That means h1 is the 3h2. Here angle of projection 60 degree, it is more than the 30 degree, but the height reaches in the first case, that is the 3 times of the second one. Now, when the height will be maximum, obviously when sin theta is the 1, when sin theta is the 1, when theta is the 90 degree. That means when the projectile is projected vertically directly upwards with the same velocity, the vertical range will be maximum. and that will be u square sine square 90 degree by 2g, that is u square by 2g maximum value. That means if you asked what will be the maximum height, that will be u square by 2g, and when the angle of projection theta is a 90 degree, that means when the bullet is fired vertically upwards, then the bullet will reach maximum height, and that is u square by 2g. For any other angles, the value will be less than u square by 2g. Now, well, we have to consider what will be the horizontal range. So, for horizontal range, it is the horizontal distance traveled by a projectile from the point of projection to the point where it hits the ground at the same level as that of projection level. That means what is the horizontal distance traveled during the flight? And we generally denote it by r. That means horizontal range is nothing but velocity of projectile along the horizontal direction into time of flight. We can write it because there is no change of the velocity along the horizontal direction for the whole path. Therefore, we can direct multiply it to find out the range, horizontal distance traveled by the projectile at the same level of projection. So, really, r is the u cos of theta, that is the velocity along the horizontal direction. Into time of flight, we have time of flight in this example, in this projection, there is a 2u sin theta by g. And by calculating, we get that is the u square whole into 2 sin theta cos theta by g. And you know 2 sin theta cos theta is sine of 2 theta. That means what will be the range? That is r will be u square sine 2 theta divided by g. It is the range. It is the range. R will be u square sine 2 theta divided by g. It is the range. The maximum horizontal range. What will be the maximum horizontal range? It is any range. Really, that depends upon the theta when u and g are constant. For the different values of theta, here r will be different. But you cannot say when theta increases, r increases. Let us see what's happened. Why we cannot say when theta increases, r increases. Because here the equation is not sine theta or sine square theta, it is the sine of 2 theta. And the formula for the sine of theta, you have to remember it, sine 2 theta is the 2 sine theta cos theta. For maximum horizontal range, that means for the same u, the projectile, the value of horizontal range depends upon angle of projection theta. And we know the maximum value of sine theta is the 1. That means r will be maximum when sine of 2 theta will be 1. And it is possible when sine of 90 degree. That is sine of 2 theta is the sine of 90 degree. Be careful about this calculation. I am saying again, the range that will depends upon the angle of projection. For the same u, when any bullet is fired by the same gun at the different angle of projection, r completely depends upon the sine of 2 theta. And when the value of sine of 2 theta is the 1, at that time r will be maximum. And sine 2 theta 1, that will be when it equal to 2 theta equal to 90 degrees. Sine of 90 degree is the 1. And from this concept, we can find out theta is the 45 degree. That means only when the angle of projection is 45 degree, the range will be maximum. If the angle is more than 45 degree or less than 45 degree, the range will be less. That means it will reach the ground before to reach the maximum distance. Then what is the maximum range? It is the expression of the range, but it is expression for the maximum range. Now, in the maximum range, this sine of 2 theta is the 1. Obviously, when theta is the 45 degree, it is the condition to attain the maximum range for the same u. R max is equal to u square sine of 2 into 45 degree. That is sine of 90 degree divided by g. That means R max is equal to u square divided by g. Hence, in order to achieve maximum horizontal range, the object should be projected at an angle of 45 degree with the horizontal. It is the condition for the to achieve the maximum horizontal range, convex angle of projection always would be 45 degree. And what will be the value of that maximum range? That is u square by g. Already we have maximum vertical range, that is u square by 2g, and it is the maximum horizontal range, that is u square by g. There is a relationship between it. That means if you take the same gun, when it is directly vertically fired, the bullet will reach up to distance that is u square by 2g. And if you make an angle theta is the 45 degree, then it will reach the double distance, that is u square by g. In the previous case, that was u square by 2g. But when you make an angle 45 degree, the horizontal range will be double of the maximum vertical range. So for when we throw any object, javelin throw, or any throw, or high jump in place of high jump also, you have to make an angle 45 degree with the horizontal as well as with the vertical also. Then your range of this projectile will be maximum. And generally it is obtained by practicing several times. We have to find out the angle of projection is 45 degree. How can we project with the angle 45 degree so that it will reach the maximum horizontal distance? Now another fact, also interesting fact, here already we have stated that when theta increases, it does not means the range increases. When theta increases, it means time of flight increases, vertical height increases, maximum height increases. But in case of original range, it does not show. And one interesting fact is this: for two different angle of projections, if one is the theta and another is the 90 degree minus theta, that means one angle and its complementary angle, if u same, then both will reach the same distance, same horizontal distance. That means for the angle of theta and 90 degree minus theta, if one is 30 degree and another is a 60 degree, the range will be the same. They will strike the ground at the same distance from this one projection at the same level. How can you prove it? Very simple. For normal cases, when let us suppose theta is the angle of projections, what is the range now? Now use the sine of 2 theta divided by g. In place of theta, if we project the same projectile with the same velocity u, then what will be the range? That is, let us suppose r dash, that is u square sine of 2 theta in place of theta 90 degree minus theta divided by g. Now which is equal to u square sine of 180 degree minus 2 theta, and we divided by g, and we know sine of 180 degree minus alpha is the sine of alpha. Sine of 180 degree minus any angle, that is the sine of that angle. In this case, sine of 180 minus 2 theta divided by g, that is sine square 2 theta divided by g, and that is nothing but the r range when that same projectile was projected with the angle of projection theta, and when it is projected with 90 degree minus theta, the range will be the same. It is one interesting fact. Hence, at a given velocity of projection, a projectile given velocity of projection means u same, obviously, otherwise you cannot find out it. And if u also changes, then we can find out the ratio. But when u same, the projectile has the same value of horizontal range for the angle of projection theta and 90 degree minus theta. Already we have stated the time of descent. Time of descent, it is the time taken by a projectile in falling from maximum height h to level of projection. Now, time of descent, if you write it is td, that is t minus ta, and it is that t means total time of flight, that is 2u sin theta by g minus u sin theta by g. So time of descent, that will be u sin theta divided by g. Hence, time of ascent equal to time of descent. These two will be equal to each other. Time of ascent equal to time of descent. Now our next topic is velocity of projectile at any instant of time. Let v be the velocity of the projectile at any instant of time t. when it is at point P. Here the coordinate of the P is xy. That means at that point P, there are two components of velocity along the x-axis Vx and another along the y-axis Vy. The velocity will be resultant of this Vx and Vy. Velocity V has two rectangular components, Vx and Vy. Using the relation V equal to U plus At, along the horizontal, we already know it, that will be same U cos of theta, because U Vx equal to Ux plus Axt, and Vx is the U cos of theta plus 0 into t, that is U cos of theta. Vx remain unchanged. Already we have stated several times, because there is no acceleration along the x-axis. But Vy, that will change due to the action of gravity, and along vertical Vy is the Uy plus Ay into t. Uy means U sin theta, Ay equal to minus j whole into t. Therefore, Vy is the U sin theta minus g into t, by putting the value of the Ay, that is minus g. Now, resultant velocity at point P, that will be V, that will be root over Vx square plus Vy square, because these two are rectangular components, that means perpendicular to each other. Therefore, V will be root over Vx square plus Vy square. Therefore, V, that will be by putting the value of Vx and Vy, that V will be equal to root over U cos of theta whole square plus U sin theta minus gt whole square, and that is equal to root over U square cos square theta plus U square sin square theta plus g square t square minus 2u gt sin of theta. And if we take the common U square, cos square theta plus sin square theta is the 1, and V will be root over U square plus g square t square minus 2u gt sin of theta. It is at any instant what is the value of the velocity. If the velocity V makes an angle beta with the horizontal at any point during the motion of the projectile, that means, since we are considering the velocity, it is a vector quantity, we have to give the directions also, and we give the directions with the help of angle. Let us suppose beta is the angle of this resultant velocity V, or velocity V at point P with the x-axis, and tan of beta is the Vy divided by Vx. Putting the value of the Vy Vx, we can find out the tan of beta, that is the U sin theta minus gt divided by U cos of theta. And from this equation, we can also find out the beta, that means directions. Now, some special cases. Let us suppose at the maximum height when t is the Ta, that means U sin theta by g. It is the time, ascent time, the time taken to reach the maximum height, that is U sin theta by g, already we have known. That means at the maximum height, what will be the resultant velocity? Egt will be 0. Let us see. V is the root over U square plus g square t square. In place of t, we have to put U square sin square theta by g square minus 2u sin theta in this equation. 2u sin theta, in place of t, we have to put U sin theta by g. Here g square cancel out, the U square plus U square sin square theta, and here g cancel out, 2u square sin square theta, and from this we get U square plus U square sin square theta minus 2u square sin square theta, which is equal to root over U square minus U square sin square theta, which is equal to root over U square 1 minus sin square theta, and 1 minus sin square theta is nothing but a cos square theta. Then V is the V cos of theta. That means at the topmost point, Vy0, and the total velocity is equal to the velocity or component of the initial velocity along the x-axis. That means throughout the whole path, it will remain unchanged. At the maximum height, we find out here in the different way, that is equal to the U cos of theta. And at that time, we can easily find out what is the angle u sin theta, tan of beta is the u sin theta minus gt. Gt means u sin theta by g, and from this it is the 0 by u cos of theta, that is the 0. Tan of beta 0 means beta is the 0. So the highest point, at the highest point, the velocity of the projectile is only along the horizontal direction. Now, velocity of the projectile at the end point, that is at t equal to t, when at the end of flight, that means when the object is reached at the same level, or it will reach at the or strike the ground. At that time, we have to take that t equal to capital T, that is the time of flight, that is u sin theta by g. Similarly, again putting the value in this equation, v is equal to root over u square plus g square t square minus 2 u gt sin theta. Here u square plus g square t square means 2u sin theta by g whole square minus 2u into g into in place of t, that is 2u sin theta divided by g, it is time of flight, and into sin theta. And from this equation, v equal to u square, now g square is the 4u square sin square theta minus 2 into u into g into 2u sin square theta, sin theta into sin theta divided by g. And these g cancel out each other, g square cancel out each other, and from that we get v equal to root over u square plus 4u square sin square theta minus 4u square sin square theta, and the plus and minus they cancel out each other, and which is equal to root over u square, therefore v the u. That means it is a very interesting fact, the which is equal to the initial velocity, and that will be the same when it strike the ground, that means when it reach the same point, the speed will be the same. And if you want to find out the directions, the tan of beta, that is u sin theta minus gt divided by u cos of theta, and here tan of theta minus gt divided by u cos of theta. Here t is the total time of flight. If you put the value of the t here, that will be tan of theta minus 2 tan of theta, that is tan of beta is the minus tan of theta, beta is the minus theta. The negative sign of beta shows that the projectile is moving downwards. Thus, in projectile motion, a body returns to the ground at the same angle and with the same speed at which it was projected. It not depends upon the angle of projections. That means even if you project any object directly vertically upwards with some initial velocity, it will return back at the same height with the same velocity but opposite in directions. Just like any other angles also, the u will be the same, because here there is no other force acting on the object or projectile, only the gravitational force acting on it. And in future you will know the gravitational force, it is a conservative force, and under a conservative, when any object is moving under a conservative force, there will be no change of the total energy here, total kinetic energy also remain unchanged. In future, we can also get the similar result with the help of the concept of the law of conservation of energy. Here, with the help of this simple mechanics, we get the angle of the speed or velocity of the projection when it will return back at the same level, that will be the same. Now, in all above treatment, we are considering the theta, that is the angle with the horizontal directions. Sometimes if you asked what will be the different expressions if the angle theta or angle of projection, we consider theta with the vertical directions, then uy the u cos of theta in this case, if theta is the angle of the u and this angle with the vertical, then we have two components. One is the ux, that is u sin theta, another is the uy, that is the u cos of theta. Here we get the component along the y-axis, that is cos component, along the x-axis there is the sin component. Let us the projectile is projected fired at an angle theta with vertical. Resolve u into its component. Ux is the u sin theta along the ox, and uy is the u cos of theta along the y. Let us at any instant of time t, projectile is at point P, that is xy. Angle theta with the vertical is equivalent to angle 90° minus theta with the horizontal. Therefore, replacing theta by 90° minus theta in the various formula already we obtained, then we get all the formula in this situation also. As for example, number one, path of projectile, that is equation of the projectile trajectory. Y is the x into tan of 90° minus theta in place of theta, if we place tan of 90 minus theta, minus g square x square 2u square cos square 90° minus theta. In place of theta, we here replaced it by 90° minus theta. Therefore, y equal to x cot of theta. 90 minus theta means cos of theta, minus g square x square whole divided by 2u square sin square theta. Here cos of 90° minus theta, that is sin theta. That means in this equation tan convert cot, and for this equation cos convert sin. Maximum height again, here u square sin square in place of theta, we have to put 90° minus theta, that is divided by 2g. The h max equal to u square cos square theta divided by 2g. That means the equation here sin square theta, here it will be cos square theta. In place of sin, there will be cos. Time of ascent, again also in place of u sin theta by g, you will get the u cos theta by g. Time of flight, again in place of 2u sin theta by g, you will get sin of 90° minus theta, that means cos theta 2u cos theta by g. And time of as descent, that is also u cos of theta by g, but there will be no change in the horizontal range, because u square sin of 2 into 90° minus theta by g, that is u square sin of 180° minus 2 theta by g, and sin of 180° minus 2 theta is nothing but sin of 2 theta. Therefore, this expression remain unchanged if theta is either with angle with the horizontal direction or the vertical direction. Now, velocity of the projectile, in place of sin, you get the cos. Obviously, for other equations also, in place of sin, you get the cos. That means you have to careful about the questions. If in the questions it is given the angle of projection theta with the vertical, then you get this type of equations. And if you have to find out the equations, then according to previous one, you have to take uy the u cos of theta and ux is the u sin theta. But if you need the equations only, then you can direct put the value in place of theta 90° minus theta, and you get the required equations. That means how can you deal, that depends upon the questions. If you have to derive, then initially or you have to follow the all steps as per above conditions when theta is with horizontal. But if you only asked the find out the or write the equations, then if you know the equations for angle of projection theta with horizontal, in place of that theta, if you replace theta by 90° minus theta, you get the required equations. And interestingly, where there is a tan, that will be cot, cos will be sin, and sin will be cos. But in place of range, there will be no change of the equations. These are the all about the oblique projectile motion. And today's class is now completed.